Hi guys, Muskan Agarwal here again. So here we are with another video on database replication. But before we get started, let's understand like our previous videos. We have understood about scalability, right? How we make our system to be highly scalable. That is, we can scale out, scale in, we can scale up, scale down, and also the load balances helps us to scale our system. Also, it alternatively helps us to make our system to be fault tolerance. How? Because we can add on servers, we can remove the servers based on the incoming traffic we have, right? So it ensures scalability, it ensures fault tolerance at the data tier level. Now coming to the databases, right? How we make sure that our system is a fault tolerance at the data tier, right? We understood that there is user or the client, right? And then it communicates with the server. Server further fetches the data from the DB, right? So at the server level, we have understood about load balances, we have understood about scaling. The scaling technique, same thing applies to DB as well, but there are other concepts when it comes to database, such as sharding, partitioning. So that we will deep dive, because these are kind of big topics, so we will deep dive into them slowly later on. Now we are coming to ensure how we can make our system fault tolerance at DB level, at data tier. So for that, there is a concept of master as well as slave DB technique. So as this concept name suggests, that there is a master DB and there is a slave DB. Now what is the difference between of these two? So master DB is like any updation of the data in the databases will be redirected to the master DB, and slave DB is just to read or fetch the data from the database, right? So let's take an example of Instagram. Now Instagram pe the probability of people or the number of users who are posting daily, who are posting on their feed daily, is way less than the number of the users who are fetching, who are reading, who are just visiting the Instagram profiles of other users, right? So that means the read ratio is way too higher than the write ratio, right? So in order to maintain that read ratio, we have to maintain different DBs. We can't redirect all the read as well as all the write request onto one DB, because that will like it will overload our database with the request, right? So if, let's take an example only on the Instagram, like if we say Justin Bieber, right, and Virat Kohli, they have million of followers, right? And if there are multiple users who are trying to read their profiles at the same time, our database won't be handled, won't be able to handle the amount of read request as well as amount of data that database hold, right, for each particular I would say Instagrammer, like the Virat Kohli or Justin Bieber, right? So for that, we have to maintain either, like we have to maintain a separate database for their data, or separate shards for their data, separate partition for their data, right? So in order to ensure that the number of requests and the amount of data that the database holds does not result into a bottleneck, we will divide that. We will divide the database into smaller parts. So we have one as the master DB, we have another as a slave DB, like we can keep, let's say, so this is the master DB and this is slave DB1, this is slave DB2. Databases, or we can say them as the read replicas also. Why they are said as read replicas? Because slave databases only handles read request. No write request is redirected to the slave DBs. Write requests are always redirected to the master DBs. Understood? So whenever server tries to create new user, to update a user profile, to delete a user profile, they are all redirected to the master DBs. So like create, delete, or update, they are all redirected towards the master DBs. While we are trying to fetch a user profile, we are trying to read the post, read the stories and everything, so it goes to the slave DBs, read request, right? So why we have this concept, or why we have this design, is because first of all, high performance. It ensures system performs highly, right? So why? Because the number of write requests are comparatively lesser than the read request. So whenever you tries to reload an app or website, if it takes time, it hinders user experience. User is kind of frustrated ki, oh my god, it's taking more than 1 second or 2 seconds or 30 seconds or something, right? So in that case, we have to make sure a system is highly performant, highly available to the user. So for that, we have slave DBs, so that all the read requests are redirected to them and user can get their data as soon as possible. So highly performance, highly available. Now next is fault tolerance. How it ensures fault tolerance is, if in any situation, like let's say we have only one master DB and one slave DB. Let's not take this slave DB too, just forget about this. Just one master DB and one slave DB. Write request are redirected to the master DB, read request are redirected to the slave DB. So what if our slave DB1 goes down? It went down, right? So what will happen to all the read requests? So all those read requests will be now redirected to the master DB. So for a while, master DB will take care of all the write requests. It will also take care of all the read requests. And for that time, you can just debug the issue. You can like restart your slave DB and like all the read requests will be redirected to the slave DB or the read replica. So this is how it makes a system fault tolerance, that if any of the slave or any of the DB went down, it like master DB or the slave DB, it's able to handle the incoming load then also. Now it was the case when slave or read replica went down. Now what if our master, like the main DB, it went down? What will happen? It's not like that our system will just be collapsed completely. We won't be able to read data, anything. No, it doesn't happen this way. So any of these slave DBs will be promoted. They will be promoted to the master DB. So whatever read replicas you have in your pool, any one of them will be promoted to the master DBs. It will take place as the master DB, and all other DBs, all other read replicas will stay as it. So it will handle all the write request, and while all other slave DBs or read replicas will handle the read request, right? Now there are like how whenever a data is written or is updated into the master DB, how it is updated in the slave DBs. It is done through replication. And there are two types of replication. One is synchronous replication and another is asynchronous replication. We will cover this topic in the next video, but as of now understand that as soon as the database is written into the master DB, जैसे ही मास्टर डीबी में कोई भी डेटा अपडेट होता है या राइट होता है, वैसे ही वो तुरंत बाकी सारे स्लेव डीबीज या फिर रीड रेप्लिकास में अपडेट किया जाता है, in order to make sure that each and every DB is on same page, कि वो एक ही स्टेट पर है. ऐसा नहीं है कि मास्टर डीबी के अंदर बस डेटा राइट हुए जा रहा है, बट स्लेव डीबीज आर नॉट अपडेटेड. जैसे कि मैंने सपोज इंस्टाग्राम पे पोस्ट कर दिया, लेकिन वो बाकी सारे स्लेव डीबीज में अपडेट ही नहीं हुआ, और कोई अगर मेरी प्रोफाइल फेच कर रहा है, उसको वो लेटेस्ट पोस्ट नहीं दिख रही है. सो इट विल बी लाइक डेटा कंसिस्टेंसी यहाँ पे नहीं अचीव हो पा रही है, राइट? सो इट विल बी लाइक data consistency breach kind of thing. So in order to make sure there are multiple replication techniques, we make sure कि जितना जल्दी हो सके कम latencies के कम lag के साथ अपना डेटा सारे DBs में अपडेट हो जाए. Understood? So now our system would look like something. There is a user or a client that sends request to the load balancer, as we studied in the last video, and load balancer then redirect the request to the servers, server 3, server 4 or something. And now there is one master DB and there is one slave DB, right? So this is the data tier completely, and all the servers are the web tier. So whatever write request is coming from servers, it will redirect it to master DB, while all the read request will be redirected to the slave DB. So it's like an important concept, and when your traffic grows, when you are handling with millions of users and the lots of data, you will be relying on this design as well, master slave replica, master slave technique, or we say read replica, master read replica. I hope you understood this concept. If you have any doubts, please do drop it in the comment section. Also, do like, share, and subscribe. Thank you.